In this video, we will be doing our third graphical method to see. Now we will put these two equations on the graph this time and see whether they are consistent, dependent or inconsistent. So basically, now let us start by that. Uh, let us take the first equation, which is 2x plus 3y equals 9. We're taking the minus 9 to the other side, which becomes plus 9. So I have this equation here. Now I'm going to consider our y to be, say, 1, so that our equation is going to be like this, right? Then I know 2x and this is 3, that is 9. And then if I take the 3 to the other side, I'm gonna get 2x as 6, and divided by 6 divided by 2 is going to give me x as 3. So if I make that small point box we make, column we can say, then I'll have my y1 and x as 3. Next, let us do the second one. The second point, we will consider y to be 3, which will give us 9 already, right? If I have 3 times 3, that is already 9. So I don't need this whole term, so I'm going to consider my x as 0. Then I'm going to get my y as 3. I'll write it down if you want. So that's going to be times 0. I'm taking x0 because we'll be enough with y as 3. So that will be 3 3s are 9 and 2 zeros are 0. So 0 plus 9 is 9. It satisfies. So the other point is going to be when x is 0, y is going to be 3. Okay, now let's take our second equation. We are done with the first equation. We took 2 points for the first equation. Now the second equation, which is given 4x plus 6y equals 12. Also doing the same thing here, taking minus 12 over there, I'm gonna get plus 12. So I wrote that here. Okay, here let us consider the value of y to be, say, 2. Then I'm gonna basically have 4x plus 6 times 2 as 12, and I know 6 2s are 12, so that gives me equals to 12. And I have a plus 4x here, but I already see that 12 and 12, they are equal, so I'll just take my x value as 0. So the first point which I get, the green one, the first point which I get when x is 2, I get my when my y is 2, I get my x as 0. And now we can also do the same thing here also. Again, the 0 thing we can take this time. We can also notice that 4 is also divisible by 12, so we can consider our x to be 3. Okay, then I'm gonna have my y, if you notice, that's 12. Then if I multiply 4 times 3, I'm gonna get 12. And I have a plus 6y equals 12 here. Take the 12 to the other side, I'm going to get 6y as 0, and y is basically going to be 0 as well. Okay, now if I have my x as 3, we get our y as 0. Now let us draw these graphs here. Okay, let me draw the graph. So okay, now the first graph is when x is 3 and y is 1. So x3 is going to be here and y1 will be somewhat over there. Okay, this is our point 3 comma 1. Okay, the next one is 0 comma 3. X is 0 and y is 3, so it comes somewhat over here. So that's 0 comma 3. And our next one is this one, which has x as 0, y as 2. So x0, y2 is going to be here, and x as 3, y as 0 is going to be over here. I'll write those down. So that's 0 comma 2, and that is 3 comma 0. So if we make the lines, you can notice that they both are, this is little bit here. So if you notice these two lines, they both are parallel. So now if they are parallel, it is known as a inconsistent graph. Inconsistent graph. So why it is inconsistent? Because these two equations will have no zeros, because no solution, because if you draw the graph you can see that they never meet, because parallel lines never meet, and so when they don't have any solutions, it is known as a inconsistent graph, no solutions. So what we did in this video is we took two equations and made the graphs and saw that the lines are parallel to each other, and also if they are parallel, it means that they will never meet each other, and also they are inconsistent because they have no solution. So if you notice, if I take all this out, they both are parallel to each other. They both are parallel to each other.